Okay, let's take a look at number 14. We have a question about that one. So let's okay, here we go. Number 14.
Okay, I don't like how high this is.
Wait, can we squat down like together?
Oh, wait, I'm sorry.
So we go like 3, 2, 1, right? When I say 1, we'll squat down. 3,
Guys,
2,
don't play
1.
with the chairs.
She smiled.
Okay, number 14. Here we go. We are hiking on a level path. It looks like we're looking at a mountain. And the angle of elevation is 30 degrees. Okay, we're doing a problem now. Everybody should be paying attention. Moving 1,000 feet closer, so this is 1,000 feet closer. Now the angle of elevation is 35. How much higher is the peak? Okay. All right, so let's look at that and see if we can come up with a strategy. Anybody have a thought?
Find the bigger angle.
Yeah. Don't let the 1,000 confuse you. If you look at this, well, actually, this is a little different. Is that it? But do I have all the information in there?
No.
What else did they give me?
Wait, I'm not sure. I thought you said. Never mind.
Yeah, I do have all the information in there. I think I'm going to need a system of equations to solve this one, maybe. I think I may need to say something like the tangent of 35 equals what? What's the tangent of 35 equal?
X over Y.
X over Y. And what does the tangent of 30 equal?
X over Y plus 1,000.
Now, what have I got here, you guys? What is this? A system of two equations, two unknowns?
Yeah.
And how do I solve a system like that? How do you solve, like, you've seen systems that look like this before. How do you solve this? Two equations, two unknowns. So you could use substitution. That means get one variable by itself and plug it in to the other equation. You could also do what? Elimination. Now, looking at the two equations that we have, what do you think might be the best way to do it? Probably substitution. So let's see. It looks like if I take that top equation, does it say x equals y tan 35?
Yeah.
And the bottom one says x equals y plus 1,000 times tan 30. Now, if both of those are equal to x, then I can set them equal to each other. So y tan 35 equals y tan 30 plus 1,000 tan 30. Now, I did two things. I set them equal to each other and I distributed. Do you see that?
It's y tan 30. You're good.
Now, what am I solving for? Y. So in order to solve for y, I got to get them both on the same side of the equation. So here we go. I'm going to put them both on the same side of the equation. And then any ideas what I'm going to do now that I've got them on the same side of the equation?
Solve. Oh wait. No. Yeah.
Okay, how do I combine these? I'm going to factor out a y. So I built my two equations from my triangles, just using my tangent function. Solved both equations for x and set them equal to each other. Now I put all the y's on the same side and factor them out. So what will y end up equaling? Y will equal 1,000 tan 30 divided by tan 35 minus tan 30?
Yeah.
I'm getting y by itself. So then I can go to my trusty calculator. And as always, when you got more than one thing in the denominator, make sure you're putting it in parentheses. So 1,000 tan 30 divided by parentheses tan 35 minus. Be really careful too, kids. As soon as in your denominator or in your numerator, anywhere, as soon as you hit tan, it puts those parentheses in. Be sure you're closing those parentheses. You don't have to type in the first one, but you do have to type in the second one to close it off. What did you get for y?
I got 4,690.
That I got 4,699.36.
Yeah, that's what I got.
Now, unfortunately, that's not the answer to the question, because we wanted to know what x is, but that's easy, because what does x equal?
Y.
Y, which is on your, that's the number right here on your calculator, times the tangent of 35. So we'll just take that times tan 35. And the height of the mountain is 3290.53, and was that feet? Was that 1,000 in feet? Yeah. Yeah, that was a little bit different kind of problem. We didn't need two equations yesterday. And when we learn a little bit more, we'll be able to do this problem without doing two equations, because we'll be able to work with this triangle. Right now, we can't work with this triangle. Why? This one. It's not a right triangle. Yeah, we haven't learned those skills yet, but we're going to. They're coming up
Cool.
very soon. Don't lose sleep over it. All right, who else found something in the homework? Anybody else? Maren?
Number 10.
Number 10. Okay, I'm going to erase all this now. Number 10. Okay, so here's the ramp leading up to the overpass. Here's the ramp. This is the ramp right here. And it's 470 feet long. And it rises 32 feet. What is the average angle of inclination of the ramp? Now, angle of inclination, we haven't used that vocabulary, I don't think, but does it make sense to you that it's the incline of the ramp, so it would be that angle right there?
Yeah.
Now, does the 470, where I put that, make sense to you, Maren? Yeah, because this is the ramp. They tell me it's that long. They tell me it rises 32 feet, so its vertical is 32. And I need to find the angle. Okay, so which function am I going to use this time?
Cosine?
Who said cosine?
Khaki.
Sine.
It would be sine.
That
You
was
guys, what's the definition of sine?
opposite over adjacent?
Opposite over what?
I mean,
Yes. So 32 over 470. Now, what buttons am I gonna press in my calculator?
The
Second.
second sign.
Anytime I need an angle, I'm gonna do second sine.
Dang, that backfired.
So second sine 32 over 470. That will tell me
Be like that.
it's about 3.9 degrees.
That backfired.
Yeah, Deanna?
I just have a question. How can you put 470 on that part and like not the bottom part?
Well, let's read the question again. It says, a ramp leading to a freeway overpass is 470 feet long. The ramp is 470 feet long. So the ramp is, I mean, if, like, I don't know, I'm trying to think of a ramp right here, like, the ramp over, like, if you're,
The ramp on to get on school goes up. That ramp.
oh.
That ramp goes up.
In the hallway?
Yeah.
Yeah. Okay, yeah, think of the ramp down by the cafeteria. Okay, if I said to you the ramp is 100 feet long, you would actually measure the ramp itself, right? You wouldn't measure the horizontal distance it's covering, you would measure the ramp itself, so that's what we're doing. All right, anybody else? Good question so far, anybody else? All right, I want to do a few more of the harder ones, because I'm going to sign a few of those tonight. So, let's see.
No, it's good.
Okay, let's look at number 35.
Are you
Let's look at problem 35, same page as last night.
Yeah, you guys went to Chelsea game.
Okay, let's figure this out.
Anybody still focus on the fantasy soccer league?
Okay, problem 35. Gina's at her bagel shop, and she found that her profit is modeled by this equation. And P is in hundreds of dollars. And T is in months after January. Yeah. Now, the problem tells you that Gina has observed an up and down pattern, but that should make sense to you, because when you got a sine function involved, don't you have an up and down pattern? Now, any thoughts on how we might answer the question, which is, in what month did the shop first begin to make money?
So you're solving T. And then
Well, let's draw a picture of that on our calculators. Now, see the pi in the problem? That's a dead giveaway that what mode should you be in? Radian. So make sure you're in radian mode. Now, I want to just think about this for a second. I hope you're paying attention. I hope your brains are engaged. What does T stand for? The months. How many months are there in a year?
12.
So when I'm setting up my window, it says X, it's really T. What am I going to put in for T then? 0. What am I gonna put in for T max? 12. So it's X min max, but 0 and 12. Now I have no idea about the Y's, so
Where is that?
put something in, let's graph it and see what happens. Now, I would suggest that your Y's, mine were way too big. Oh, yeah. Okay, I have a great picture using Y's at negative 10 to 30.
It continues up.
Using Y's at negative 10 to 30, I have a great picture.
That's not how it's.
But, regardless, are you seeing part of the curve down here and then mine looks something like this? Is that what yours looks like? Now, I'm interested in problem A. It says, in what month did the shop first begin to make money? Where does that happen? Where does making money start here? Right there, right? Because P is the money. Tell me about P down here.
It is.
It's negative. She's losing money down here, right? But starting here, she's making money. So, you ought to be able to tell from your graph where that is. That point happens between the second and third month. Between 2 and 3 is where I cross there. Can you see that on your picture? Okay, remember, this is January. So this is all of January right here. This is February. So in what month did she start making money? March. That was easy. Next, in what month did the shop enjoy its greatest profit in the first year? So when you said 0 to 12, that's 1 year. Okay? So the peak is over here. That's the greatest profit. Can you tell from the picture? It's kind of hard for me. If I can't tell from the picture, I could always do a maximum. I think that's what I'll do. Because it's hard for me to tell exactly what month that is. So I'm going to do a maximum on that interval. I'm looking for that point right there. And it's going to say, that point is 10.76, 28.26. Now that means between 10 and 11, month 10 and 11, or hash mark 10 and 11, I have my greatest profit. Now, can you tell what month that would be? Remember, the first mark was January, the second mark was February. What will the 10th mark be? October, and the 11th will be November? So you okay with that? That was easy. All right, let's try another one. 30. 30? Yeah. What's 30? A point on the tip of a tuning fork vibrates in harmonic motion described by the equation D equals 14 sine. Okay. Fine. W for a tuning fork that has a frequency of 528 vibrations per second. Okay, this is a good problem. Okay, this is a really good problem. We need to back up a minute and make sure we remember something important.
WT.
Think about the quiz that you took yesterday.
So man, go.
Let's think of an easier version of that. What's the period? For this guy right here. 2 pi divided by 3. Anytime you have a sine function, your period is going to be 2 pi divided by this number, right? So what's the period of this thing? It's a sine function. Forget the variables.
2 pi over W.
The period here is 2 pi over W. Would you agree with that? Okay. Now, if the period is 2 pi over 3, what would the frequency be?
3 over
3 over 2 pi. Because we know frequency and period are reciprocal. So they tell me that my frequency is 528. What does that mean my period has to be if the frequency is 528?
1 over 528.
1 over 528. But wait a minute, you told me that the period was 2 pi over W. So doesn't that mean 2 pi over W has to equal 1 over 528?
Yeah, but I don't like that.
Isn't that what that means? So what's W? 1056 pi? Did I multiply right? So it says find W, there it is. If you're given the frequency, you automatically know the period, and vice versa. Okay? Good. All right, let's try another one.
Sorry.
Anybody else look ahead? Have a particular one you want to look at?
I was trying to make a joke, but I just didn't stop myself.
Let's try 26. Because I don't think they drew a picture for 26, so let's do that one. Remember, whatever I get done, you don't have for homework, so. Okay. I don't know what happened. First semester, you would not say a word because your eyes were closed. And now you're like a maniac.
I feel like I've been very calm. I don't.
Okay, number 26, here we go. Milwaukee, Wisconsin is directly west of Grand Haven, Michigan, on opposite sides of Lake Michigan. Okay, so Milwaukee is, so here's Milwaukee, it's directly west of Grand Haven. On a foggy night, a law enforcement boat leaves from Milwaukee, so here's Milwaukee, on a course of 105. So 105 would look like this. We talked about this yesterday. That's a course of 105 degrees. Would you agree with me? So here's the law enforcement people. At the same time that the bad guys leave Grand Haven on a course of 195. Now, does that position make sense to you, 195? The law enforcement boat averages 23 knots and collides with the smuggling craft. What was the smuggling boat's average speed?
Pirates.
Okay, so these guys are going to collide.
Okay.
Okay, now let's look at this for a second. I definitely see a triangle, do you?
Yeah.
Let's look at some angles maybe
I feel like
in that triangle.
that
How
has to be
big
a-
would this angle right here be? This guy would be 15. Would you agree with that?
Yeah.
Everybody clear? How about this one right here?
75.
What does that make this one down here? That's a 90-degree angle.
That's a great triangle.
Now, do I know how long these vehicles were traveling?
We know on 139.
I know the speed, but do I know how long they were traveling?
No, it's 15.
No. His speed, this one, the speed was 23 knots, 23 miles an hour. So I'm going to say, I don't know how long they were traveling. The length of this would be 23 t. I don't know how long he's traveling, but it's 23 times that. So 1 hour would be 23 miles, 2 hours would be 46 miles, and so on. I want to know how fast this guy was traveling, so I'll call that x.
This is 2.7.
This is going to be x times t. They leave at the same time. They leave at the same time, so they're traveling the same number of minutes. I don't know what that is. Any idea how we might find x? X is what we're solving for. Any idea how we might find it? Well, look at the picture.
You got a great picture.
We could use either angle, it doesn't really matter. If I use 15, what have I got here? Tangent. So what if I said tan 15 equals xt over 23t? What happens to the t?
Both go in straight lines.
So tan 15 equals x over 23, and x equals 23 tan 15?
Pirates like great. Grand.
And that will be the answer to your question.
What happens if it's a negative?
Whoa, whoa, oh, what?
Oh, because it's on
Why is it, no. It should not be negative. Why is it negative?
the, it's in radians.
Because, yes, you didn't switch your calculator back to degrees. Yeah, the speed should not be a negative. Now, the next one, or the one right above that, I mean, they drew a picture for you, but it looks like a complicated picture. So let's take a look at that one. This would be number 25. So the shoreline runs north and south. A boat is due east of the shoreline.
What are they trying to see? What did they do?
The bearings of the boat from 2 points on the shore are 110 and 100 degrees. Okay, that means, here's a point on the shore. That means the angle to the point is, this angle right here is 110, let's make that one 100 degrees. And then from another point to the boat, that angle is 110 degrees.
So can you just?
Assume the 2 points are 550 feet apart. How far is the boat from the shore? Oh, this is easy after one we did earlier. What's your thought on this?
Can't you make those? Can you make those right angles and then subtract?
If you look at the little triangle down here at the bottom, the little one, what do you know about this angle? 80? So if we call this y, could we say tan 80 equals x over y? Now let's look at the big triangle, the whole triangle. What's this angle?
70.
70. So could we say tan 70, what would that equal? Tan 70 would equal?
X over Y plus 550.
Perfect. And do you remember from the problem we did earlier, do you remember how to do this?
Substitution. Solve for x.
Solve for x. So x equals y tan 80, and x equals y plus 550 tan 70.
They equal each other.
They equal each other, so y tan 80 equals y tan 70 plus 550. I'm distributing also. Not only am I setting them equal to each other, but I'm distributing.
And you put the y's on both sides.
Put the y's on the same side. Now, I know what some of you are thinking. You're thinking, Miss Ford, we just went through this. Do we really have to do this again? And the answer is, you know what? You might have to do it on test day, so let's practice. Let's get good.
Take out a Y.
Take out a y. And finally, the last step will be to, well, not the very last step, but the next step will be to, what?
To divide.
To divide. Very good. When I type this in on my calculator, please make sure your denominator is in parentheses. Please make sure you close the parentheses after each angle. Otherwise, it won't work. Now, what happened this time is exactly what happened last time. This is what we're solving for. We didn't get it, we got this, right? So go back to one of your equations here, probably the top one. You have this number sitting on your calculator right now. It's like 2,700. You need, just take that times tan 80, and that gives you the answer to the question. 24,918.82, and was that feet? Yeah. Okay, that's your answer.
Wait, what?
Any question about that? Well, I've done almost all your homework problems, so I want to stop now and have you get out your smaller packet. Tonight's homework is in the book. We're getting a little bit of a head start here. Yeah, that's right. Okay, would you, in your smaller packet, which is your review sheet packet, would you find the paper that says review sheet? It says Precal A, review sheet 4. Yeah, the smaller packet that has all the review sheets in it. Find the one that says review sheet 4. I don't want the one that says pretest, I want the one that says review sheet 4. This has a lot of problems on it. But there are two that I want to look at particularly because we have not done this yet. Take a look at number 12.
I don't know what page it is.
Okay, it's on the paper that says at the top, Precal A, review sheet 4. Now, some of you, after grading your quizzes, some of you are still struggling with your sketching. So hopefully this might help you, I don't know, because what we're going to do now is go backwards. There's the picture. It's been drawn for you. Now you're going to write not one, but two equations for this curve. And the reason that you're going to write two equations is you understand that this goes on forever and ever and ever. You understand that depending on what part of this you look at, it could be a sine or a cosine. So you are going to write a sine equation and a cosine equation. Now, let's not be fearful. A lot of blanks in there, but every blank has a purpose. Think about a question like on your quiz. I'm making this up, I don't remember the quiz question. But there's an equation. You have a number here, a number here, a number here, and a number here. Those are the blanks that you're filling in. But each of those has a purpose. What is the purpose of this number? What does it have to do with?
Amplitude.
Amplitude. So when I look at this picture, and let's just start with the part that I drew. What's that look like? What shape is that? That's a sine. So let's just fill in the top one. What is the amplitude of this curve? You can tell by looking at it. What's the amplitude? 4. So we're going to put 4 up here. Now be careful. Is the curve right side up or upside down?
It's right side up.
Right side up. So that's a positive 4. It could be a negative 4, right?
Yeah.
If the picture were upside down. Okay. What does this number do?
Period.
That affects the period. It actually divides the period, right? Now, what's the period of the picture on the board? If you're looking from dot to dot, the period is 4 pi over 3. So the period of the picture you have before you is 4 pi over 3. What's the period supposed to be?
2 pi.
2 pi. So apparently there is a number here that has changed the period, right?
Yeah.
So I don't know, let me call that n for a moment. 2 pi divided by that number
1.5.
has given me my new period. Do you see that? There must be a number here that has divided 2 pi to end up with that period. So 6 pi equals 4 pi n. So n equals 6 pi over 4 pi, which is
1.5.
3/2.
Yeah.
Now, that isn't complicated. Don't let it be complicated. You can tell from the picture the period is 4 pi over 3. It's supposed to be 2 pi. So we've divided. 2 pi divided by some number gave me 4 pi over 3. There's the arithmetic. That number's 3/2. Now, what does this number do?
Horizontal shift,
Horizontal phase shift, right?
which is
Does this one have a phase shift? Nope, it starts right where it's supposed to. So I'm just gonna put 0 there. You can just leave that out. You don't even need to put that in, but since I have a blank, I'm gonna go ahead and put 0 in it. What does this number do?
It's the reverse shift.
Has this one been shifted up or down?
Uh-oh.
No, you can tell that because it's going up 4 and down 4. It's perfectly balanced. So, there's a 0 on that too. So if you wanted to simplify that, that's y equals 4 sine 3/2 x. Does that make sense to you? All right, we'll continue this discussion tomorrow. Stephen, are you chewing gum again today?
No.
Yeah.
I blew a bubble. I'm so stupid.
You blew a bubble.
Yeah.
Whoa, oh my gosh. It's not a part of the club.
Have a good day.
I blow a bubble? Blow a bubble? I don't know. I feel like I thought Katie was correcting me in my brain. I'm pretty sure I was correct.
She was speaking about what
It's when I went to
Winklevow. I thought she said blow.
Fort Eagle. Yeah, so you, if you can't do it, then it's with glow. Free spirits, can't be taken.
Oh, can you hit that? Thanks.
You got
We
it?
have the back-to-back-to-back last place.